Hello everyone, welcome to my channel. Let's have a quick review of the topic adiabatic process. This video is for students who are going to appear their JEE main and NEET examination in the year 2018. Okay, so see, for adiabatic process, pressure, volume, temperature, all these three thermodynamical variables, they can change. Okay, they can change, but heat cannot change. Heat, no change. Okay, now if there is no change in heat, that means heat is constant. So that means delta Q is equal to 0 or dQ is equal to 0 for adiabatic process. Okay, now from first law of thermodynamics, we have dQ is equal to du plus dW. Okay, now since for adiabatic process this quantity is 0, that gives du is equal to dW, or I can write it as minus dW, sorry, or I can write it as du is equal to minus pdV. Okay, now if there is expansion, now in that case dV will be greater than 0 because volume is increasing. That means dV is positive. Now if dV is positive, that means du is negative. du is negative. Now du is negative, that means the internal energy of the gas or the system, it is decreasing. Now if internal energy is decreasing, that means temperature is also decreasing. Okay, so that means in adiabatic expansion, the temperature of the gas will decrease, its internal energy will decrease. Now see what happens in compression, adiabatic compression. Now adiabatic compression, volume will decrease, so dV is negative. Now if dV is negative, this minus minus cancels out, so we have du is positive. That means internal energy of the system will increase. Now if internal energy of the system is increasing, that means temperature of the system will increase. So in adiabatic process, in adiabatic compression, the temperature will increase. In adiabatic expansion, the temperature will decrease. Okay, now this is another concept. Now next concept is, not a concept actually, formula for work done. Okay, work done is, suppose initial volume is V1, final volume is V2. So work done is integral V1 to V2, total work done when the volume changes from V1 to V2. V1 is the initial volume, V2 is the final volume. So this is the general expression for work done. Okay, now in terms of pressure volume for adiabatic process, it is 1 by gamma minus 1 P1 V1 minus P2 V2. What is gamma? Gamma is the adiabatic gas constant. It is Cp by Cv. Cp is the molar specific heat at constant pressure. Cv is the molar specific heat at constant volume. This is in terms of pressure and volume. Now in terms of temperature, it is W is equal to 1 by gamma minus 1 into multiplied by Nr into T1 minus T2. Okay, remember it is gamma minus 1 and here it will be initial values minus final values, P1 V1 minus P2 V2, similar T1 initial temperature, T2 final temperature. Okay, now another critical observation with regard to adiabatic process. For adiabatic process, the gas equation is PV power gamma is equal to constant. PV power gamma is equal to constant. Okay, now if you have a PV graph and you have to find the slope of the curve, that is, the slope of the curve will be dP by dV. Now if PV power gamma is equal to constant, this gives dP by dV is equal to minus gamma times P by V. Whereas for isothermal process, dP by dV is equal to minus P by V. Now gamma is greater than 1, so that means this quantity is more negative than this for isothermal process. So that means if you have two curves, so this curve is much steeper than this. Okay, for isothermal slope is minus P by V, for adiabatic slope is minus gamma times P by V. So this is much it's much more negative as compared to this, because gamma is greater than 1. So that means this curve represents adiabatic curve and this represents isothermal process. Okay, so this is an isotherm. Okay, now this is if you have to compare between isothermal and adiabatic. Okay, but suppose you have, it is given that all the curves are adiabatic and there are 3 curves, and you have to identify which is for monoatomic, which is for diatomic gas, which is for polyatomic gas. Now as we can see, dP by dV is equal to minus gamma times P by V. Now gamma for monoatomic it is 1.33, for diatomic it is 1.4, for polyatomic it is 1.67. So that means this represents monoatomic gas, this represents diatomic gas, and this curve represents polyatomic gas. Okay, because for polyatomic gamma is 1.67, for diatomic 1.4, for monoatomic it is 1.33. So these are the few critical observations with regard to adiabatic process. So before you solve the problems based on adiabatic process, go through these concepts and then solve questions based on these concepts from previous years. In these next few days, solve as many past papers as possible. Okay, that will give you a very added advantage for your test, final test. Good luck.